Hi, today we're going to be talking about logarithmic functions. So let's start by defining what that is. So a logarithmic function is just a way to kind of rearrange an exponential function or equation. More specifically, it says that for a b and an x that are greater than 0 and a b that's also not equal to 1, we have that b to the y equal to x is equivalent to log base b of x equal to y. So what this logarithm is doing is it's telling you b to what power gives us x. So it's answering the question of what exponent of b gives us a number. So let's kind of keep that in mind. So for example, if we have log base 4 of 16, what I want to do is I'm asking, well, what power of 4 is equal to 16? So it should be pretty clear that 4 squared is equal to 16. So we can say that log base 4 of 16 is 2. So what if we have the equation b equals log base 5 of the square root of 5? Well, using this, we can say 5 to the power b is equal to the square root of 5. And I know the square root of 5 is the same thing as to the 1/2. So I can tell b is 1/2. What if we have c is equal to log base 3 of 1 over 27? Well, what this is saying is that 3 to the c is equal to 1 over 27. And I recognize that 1 over 27 is 1 over 3 to the third, which is the same thing as 3 to the negative 3. So I can see that c is negative 3. And what if we have log 12 of 1? Well, I'm asking us, what power of 12 gives us 1? Well, here I know that anything to the 0 power gives me 1. So we can say log base 12 of 1 is 0. And what if we have log base 8 of 8? Well, it's 8 to, well, what power of 8 gives us 8? Well, that's silly. It's always just going to be 1. So that should help refresh our memory a little bit about how we use logarithms to evaluate things. Let's look at some more basic properties. So in situations where our b and our x are positive and b is not equal to 1, the following 4 properties hold. Log base b of 1 is 0, regardless of what that b is, provided, of course, that it's positive and it's not equal to 1. Log base b of b is equal to 1. log base b of b to the y is equal to y, and b to the power log base b of x is equal to x. So in particular, these last two properties are very important because what they're really showing is that a log base b and an exponent base b are acting as inverses of each other and canceling each other out. And we're going to take good advantage of that throughout the rest of this chapter. So a little bit of vocabulary. So there's two abbreviations that we use for logarithms. The first one is the common logarithm, which is log base 10. And we abbreviate this as just log. So whenever you don't see a base for a logarithm, you can assume that its base is 10. The second is called the natural logarithm. This is log base e. And if you remember back to your Algebra 1 class, or your Algebra 2 class from last year, e is an irrational number that's about 2.718, yada, yada, yada. So again, we're going to use a special abbreviation here. So we use the letters ln, is the same thing as log base e. Okay, so let's look at some examples here using these new definitions along with what we've learned previously. So let's say that we wanted to solve the following equations. A equals log of 1,000. So what I can do is I can say, okay, 1,000 to the power a, so it's 10 to the power a should give me 1,000. And I know 1,000 is 10 to the third, so here we have a equals 3. So let's say we have the equation b equals log square root, or fifth root of 10. So again, it's 10 to the power b should give me the fifth root of 10. So I can say 10 to the b equals the fifth root of 10. And remember that a fifth root is the same thing as a 1/5 power. So b is 1/5. C, we have log of, or c equals log of 0.01. So again, this means 10 to the power c is equal to 0.01. Oops. And remember that 0.01 is 1 out of 100, which is the same thing as 1 over 10 squared, which is 10 to the negative 2. So c is negative 2. Let's say we have the equation d equals e to the ln of 5. So remember here that log base b and exponent base b act as inverses. They cancel each other out. We saw that right up here in these two properties. So what I can say here is just those cancel each other out, and we're left with that d is equal to 5. So d equals, and then 5. and we have 2 is equal to log of x. So 10 to the power 2 should give me x. So clearly x here is 100. And the last one, natural log y is equal to 5. So again, we have e to the 5th should give me y, or y equals e to the 5th. So there's that. We can also use our calculator to express the values of logarithms. So we can do that kind of 3 ways. So if you open up your calculator, if I wanted to do let's say the log of 51.37. Well, you'll notice on the left-hand side of your calculator is the button log, and I can just type 51.37 and press enter. So that's about 1.71. We'll round that to 3 decimal places maybe. And then if I wanted to do something like the natural log of 12, you notice right below the log button on your calculator is the natural log button. So I can do the natural log of 12. And that'll equal 2.485, about, rounded to 3 decimal places again. What if I wanted to do log base 12 of 18? Well, most of us have calculators that can handle this. So if you press the math button here on the left-hand side, and then scroll down till you find the log base command, it'll allow you to type in the base for your logarithm and then the argument for your logarithm and just press enter. If some of you guys have an older calculator, that may not be able to handle that, in which case we need a different tool here. So this is called the change of base formula. And what this says is that log base b of a is equal to log of a over log of b. So what I can do here is, if I didn't have this log base option on my calculator, I can do log of 18 divided by log of 12. And I should get the same decimal here. Let's just check to make sure it does indeed work. And you'll notice I get the exact same decimal. So it doesn't matter to me which way you would evaluate these things on your calculator, just as long as you're able to do that. Now, what I want to talk about are 3 other properties of logarithms. So these have names. The first one is called the product property. It says log base b of x times y is equal to log base b of x plus log base b of y. The next one is the quotient property. It says log base b of x over y, or x divided by y, is equal to log base b of x minus log base b of y. Notice the numerator is the positive part and the denominator is the negative part. And the third one is the power rule. And what this power property says is that log base b of x to the c is equal to c times log base b of x. So there's two kinds of problems that we're going to ask you to do using these properties of logarithms. The first kind is called expanding, where you're going to take a single logarithm and write as the sum or difference of many logarithms. And the other type is condensing or compressing, where you're going to take the sum or difference of many logarithms, and we're going to ask you to rewrite that as a single logarithm. So let's look at a couple of examples of these types of problems. So worth noting, for expanding, we want to look at using these properties in a specific order. We want to do quotient first, and then products, and then powers. So in example A, we have log base 3 of 4x. Notice that there's no division going on there, so there's no quotient property to do. That's the first thing we would check for. But since there's no division, there's no quotient property, so I'll move on. The next thing we'll look for is product properties. Hopefully you see product property. There's a single product property because we have one multiplication happening between the 4 and the x. So if I apply the product property here, I get log base 3 of 4 plus log base 3 of x. Okay? And the next thing you'd look for is power properties, and you might think there aren't any, but there really is one. It's hiding on you. Notice that the number 4 we can really think of as 2 squared. So there is a power property going on here. So I can rewrite this as log, or 2 times log base 3 of 2 plus log base 3 of x. Let's do another. So here we have log of 3ab to the 5th. So again, the first thing we look for is division. Now there's no division going on. So the next thing we'd look for is product property. I notice that there's 2 multiplications going on, so we have 2 product properties. So when I apply that product property, I would get this. The next thing I'm going to look for are power properties, and the last thing, really, I'm going to look for is power properties. So there's no power property here because this is we have 3 to the first, and 3 can't factor any further because it's prime. Here we have a to the first, but here we have b to the 5th. So here we have another power property. So to finish this problem off, the first 2 logarithms aren't going to change, but that last logarithm is going to turn into 5 times log of b. And let's do one more. So this will be the most complicated, and here's about as complicated as I would expect things to get. So again, first thing we look for is quotient property. So I definitely see division going on, so I will apply the quotient property. So I'm going to have the numerator minus the denominator. And now the next thing I'm going to do is apply my product properties. So the only place I see a product property is going on is between the 2 and the x here in the second logarithm. So that first logarithm I'm just going to recopy. And here I'll write my product property. But what we wrote here is not correct. And this is an easy mistake to make, but this is not correct. Take a minute and look at this and see if you can figure out where the mistake is. So notice that this negative sign is applying to the entire log 2x. So when I apply the product property, whatever that log 2x turns into also needs to be negative. So we need to make sure we're distributing that negative sign. So it should really be this. Okay. And the last thing we're going to look for is power properties. Now, log of 2 and log of 3 are both to the first power, and 2 and 3 are both prime numbers, so there's no power property that can go on there. However, the square root of x cubed minus 5, there is a power property going on there. Remember that a square root is the same thing as a 1/2 power. So when I apply that power property, I get this, and this is my final answer. Now, I want to be clear here for a moment, because this is a place where I see students make a mistake also. I'll see students do things like this. This is very bad. They'll take that and turn it into this. Now, logarithm is not a number. It doesn't distribute. It's an operation. And really, no operations other than multiplication division that we've seen in this course, or really any of your prior math courses, distribute. Please do not distribute a logarithm. Okay, so that's some examples of expanding problems. Let's now look at some condensing problems. So condensing is the opposite process. So here we're going to use the opposite order of our properties. So we're going to look for powers first, and then product, and then quotient. So let's look at some examples. We'll just do a couple here. So again, we're going to be using these properties of logarithms. So when we're doing expanding, we're looking at this side, but when we're condensing, we're going to be looking for this side. So when I go to look for power properties, I'm going to be looking for coefficients. Quotient properties, I'm going to be looking for subtraction. And product properties, I'm going to be looking for addition. So again, we want to look for power properties first. So I see two power properties going on here. So this first one, I'll just recopy. And the power property is saying is that coefficient is just going to turn into an exponent. The next thing we're going to do is look for product properties. So I see addition here. That's my indication for a product property. So those are going to turn into the product inside of the single logarithm. And next thing I'm going to do is look for my quotient property. So I'm looking for subtractions. So I got one there. So again, the positive part is the numerator, and the negative part becomes the denominator. And there I'm left with a single logarithm. It's worth noting, had, for example, the base of this logarithm been different, you'd be done at that point. So just keep that in mind, that the bases for these, in order to use these product, power, or quotient properties, they must have the same base on your logarithm to continue. If you didn't have that, you would be done. So let's do this one last example here. So again, we're going to look for power properties to start. So remember the power property, what we're looking for is a coefficient. We have a coefficient in each of these. So those coefficients are just going to turn into exponents. Now we have to be a little bit careful here because this 3 is going to apply to the a and the b together. So I'm going to write it that way. And remember here, when I have an exponent of a product, that exponent applies to both parts of my product. Okay, so next thing I'm going to do, look for a product property. And this is kind of odd because we've written it in a funny order here. But I would have a power property going on between these two. Remember that we can add things in any order we want. So these are both positive parts. I can add them together. So that's what I'm going to do. And then we can do our quotient property here as our final piece. And I'll notice that, hey, I'm left with something that can reduce. That's nice. So we can do that. And what we're left with then is just log of a over b. And that'll do it here for section 15.3. In the next section, you guys will be using these logarithms to do some solving problems, which will be a lot of fun. But for this assignment, I need you guys to work on 37 through 68 and also 71 through 98. Now, I get that that's a ton of problems, but I think it's the only assignment I need you to do for this week. So my apologies, but you should get really good at this and have a lot of practice. Not much of a consolation. Anyways, have a good day. See you next time.